Myself, k.vijayan, and I'm going to deal with the topic the slopes of isothermal and adiabatic curves. As an introduction, we can just look what an isothermal process and an adiabatic process is. First, isothermal process, a process in which the pressure and volume change at constant temperature. That is, delta T is equal to 0. Here, the internal energy of a perfect gas depends only on its temperature. We can say that dU is equal to 0. Then, first law of thermodynamics. dQ is equal to du plus dW. Here, du is equal to 0. Therefore, dQ is equal to dW. Next, we can see the work done. Work done is expressed in two forms. First, in terms of volume. W is equal to nRT into ln of Vf by Vi. Vf is the final volume and Vi is the initial volume. Next, in terms of pressure. nRT into ln Pi by Pf. Pi is the initial pressure and Pf is the final pressure. Adiabatic process. No heat exchange occurs between the system and the surroundings. Here, Q is equal to a constant. Therefore, dQ is equal to 0. And we know the first law of thermodynamics that dQ is equal to du plus dW. Here, since dQ equal to 0, we can write du is equal to minus dW. That means if the work is done by the system in an adiabatic process, the internal energy decreases. So, next work done. W is equal to nR into T1 minus T2 all divided by gamma minus 1, and one more equation is there. W is equal to P1 V1 minus P2 V2 all divided by gamma minus 1. Here gamma is called the adiabatic constant. Next, moving on to the topic, the slopes of adiabatic and isothermal curves. Slope of an isothermal process. An isothermal process is a process that occurs at constant temperature, and the equation of state of an isothermal process for a perfect gas is given by PV equal to a constant. Here P is the pressure and V is the volume. PV is equal to nRT, and this is the ideal gas equation. Here P is the pressure, V is the volume, N is the number of moles, R is the universal gas constant, and T is the temperature. Here, N and R and also T, since it is an isothermal process, are constants. So, PV is equal to a constant. Here we can see a graph. Pressure on the y-axis and volume on the x-axis. Graph between P and V in an isothermal process is called an isotherm. That means that curve is known as an isotherm, and it is a rectangular hyperbola. Then we know that as the pressure increases, here the volume decreases, and from the equation PV is equal to a constant, we can write P1 V1 is equal to P2 V2. PV is equal to a constant. So we need to find the slope, that is dP by dV. So taking differential on both the sides, here we apply the product rule, that is first function into derivative of second plus second function into derivative of first, and the derivative of a constant is equal to 0. So here the first function is pressure and the second function is volume. So P into dV plus V into dP is equal to 0, and taking V dP to the other side, we get dP by dV is equal to minus P by V. Here dP by dV is a slope, and that is equal to minus P by V. And here we can see a negative sign, and that shows as the pressure increases, the volume decreases. Slope of an adiabatic curve. An adiabatic process means no heat exchange happens between the system and the surroundings. The equation of state for an adiabatic process of a perfect gas is given by P V raised to gamma equal to a constant. P is the pressure, V is the volume, and gamma is the adiabatic constant, and that is equal to Cp by Cv. Cp is the molar specific heat capacity at constant pressure, and Cv is the molar specific heat capacity at constant volume. A PV diagram drawn during an adiabatic process is called an adiabatic. P v raised to gamma equal to a constant. We need to find dp by dv, that will be our slope. For that, we need to differentiate the given equation. For that, here the first function is pressure and the second function is v raised to gamma. So the product rule is first function into derivative of second plus second function into derivative of first, and the derivative of a constant equal to 0. Here p into derivative of v raised to gamma plus v raised to gamma into derivative of p equal to 0. We need to find the derivative of v raised to gamma. We know that d by dx of x raised to n is equal to n into x raised to n minus 1. Similarly, dv raised to gamma equal to gamma into v raised to gamma minus 1 dv. And the equation becomes p into gamma into v raised to gamma minus 1 dv plus v raised to gamma into dp equal to 0. So taking v raised to gamma dp to the other side and rearranging, we get dp by dv is equal to minus gamma p v raised to gamma minus 1 all divided by v raised to gamma. So here we can see the v raised to gamma on the numerator and the v raised to gamma on the denominator can be cancelled. So we get minus gamma p v raised to minus 1. So dp by dv is equal to minus gamma p by v, and that is our slope. Slope of an isothermal process dp by dv is equal to minus p by v, and the slope of an adiabatic process dp by dv is equal to minus gamma p by v. So these two equations have already been derived, and comparing those two, we get the slope of an adiabatic process is equal to gamma times slope of an isothermal process. So here we can see a graph, pressure on the y-axis and volume on the x-axis, and two curves, one represent isothermal and the other represent adiabatic. Here the adiabatic curve is much steeper and having more slope. As gamma is greater than 1, the slope of an adiabatic curve is greater than the slope of an isothermal curve. Gamma is equal to Cp by Cv. We know that Cp is greater than Cv. Therefore, we can say that gamma is always greater than 1. Then here a graph is given, pressure on the y-axis and volume on the x-axis. Here we can see two curves. One is represented as A and the other is marked as B. We need to find which is adiabatic and which is isothermal curve. For that, we need to consider the slope. So we need to draw two tangents. One tangent passing through A and the other passing through B. And here you can see two angles, theta 2 and theta 1, that are marked in the figure. By looking, we can understand that theta 2 is greater than that of theta 1. Therefore, tan theta 2 is greater than tan theta 1. Here tan theta means it is the slope, that is dp by dv. So by looking, we can understand that the slope of B is greater than the slope of A. So we can say that A is isothermal expansion and B is adiabatic expansion. Here it is said expansion because as the pressure decreases, here the volume is increasing. The arrow mark indicates in such a way that the volume is increasing. അതായത് ഇവിടെ നമ്മൾ നോക്കാൻ നേരത്ത് ഈ രണ്ട് കർവും ഏതാണെന്നാണ് കണ്ടുപിടിക്കേണ്ടത്. സോ ഇതിൽ ഏതിനാണോ സ്ലോപ്പ് കൂടുതൽ അതായിരിക്കും അഡിയാബാറ്റിക് കർവ്. അപ്പോൾ നമ്മൾ ടാൻജൻറ്റ് വരച്ച് നോക്കാൻ നേരത്ത് നമുക്ക് മനസ്സിലായിരിക്കുന്നു ബിക്കാണ് എയിനെക്കാട്ടിലും സ്ലോപ്പ് കൂടുതൽ, ബി ആണ് ഒന്നും കൂടി സ്റ്റീപ്പറായിട്ട് നിൽക്കുന്നത്. സോ ദാറ്റ് വിൽ ബി അഡിയാബാറ്റിക് കർവ്. Here another graph is given, pressure on the y-axis and volume on the x-axis. Here we can see two curves, one is marked as A and the other as B. We need to find which is adiabatic and which is isothermal curve. So by looking that, we can understand A has greater slope and is much more steeper than B. അതായത് ഇവിടെ എയ്ക്കാണ് ഒന്നും കൂടെ സ്ലോപ്പ് കൂടുതൽ, അതാണ് ഒന്നും കൂടെ സ്റ്റീപ്പറായിട്ട് നിൽക്കുന്നത് ബീനെക്കാട്ടിലും. സോ ഏതിനാണോ സ്ലോപ്പ് കൂടുതൽ അതായിരിക്കും അഡിയാബാറ്റിക് കർവിനെ സൂചിപ്പിക്കുന്നത്. സോ ഹിയർ A will be adiabatic compression and B will be isothermal compression. ഇവിടെ compression എന്ന് പറയുന്നത് because here the volume is decreasing. The arrow mark indicate in such a way that the volume is decreasing. So let's discuss a short question. A gas occupying 1 liter at 80 cm of mercury pressure is expanded adiabatically to 1190 cm cube. If the pressure falls to 60 cm of mercury in the process, reduce the value of gamma. So here we need to find the value of gamma, and all the necessary things are given in the question. That here it is said that it is expanding adiabatically, so the equation we need to use is P(V) raised to gamma equal to a constant. From that, P1 V1 raised to gamma is equal to P2 V2 raised to gamma. So P1 is given 80 cm of mercury and P2 is given as 60 cm of mercury. V1 is given as 1 liter, that is equal to 10 raised to 3 cubic centimeter, and V2 is given as 1190 cubic centimeter. So substituting in the equation, we will get 8 by 6 is equal to 1190 divided by 1000 all raised to gamma. So we need to find the value of gamma. So we are applying log. So log 4 by 3 is equal to gamma into log 1.190. And then solving that, we will get gamma as 1.65. So the slope of an adiabatic process is greater than the slope of an isothermal process. So we can say that the slope of an adiabatic process is equal to gamma times the slope of an isothermal process. So thank you.